Hello everyone, welcome to another session of power repair training. In this session, we're going to troubleshoot a power supply based on a flowchart and algorithm. So stay with us. Why are we intending to proceed with a procedural or a flowchart approach in this training? Because when you open up a power supply, you shouldn't proceed randomly and troubleshoot the power without a plan. In such circumstances, we waste a lot of time and can't troubleshoot a power supply properly. However, if we have a procedure, we know easily where to start, which problem relates to which part, and so on. Therefore, we can troubleshoot the power supply quickly this way. In the first step, we have an overview of the power supply's input path. When connecting the power supply to the electricity, you should inspect and test the path of the electrical input and its components. If you see any suspicious component, test it, and if it's faulty, replace it. One of the most important components in the path of electrical input to the power supply is the fuse, which is usually a glass fuse. You should examine this fuse to see if it's blown or not, because if the fuse isn't blown, it means the power supply has no connection, and if it's blown, it indicates that the power supply has a connection in its circuits, especially in a primary circuit. So ultimately, in this primary path, there are sometimes capacitors or coils. In this path, if there are no capacitors or coils, we test the fuse. If capacitors and coils exist, we also test them. The main input path starts from the input socket and then reaches the fuse. And from the fuse, it enters the diode bridge. In fact, the path up to the input terminals of the diode bridge is considered the input path. And if you encounter any issues along this path, you must address them. The next step is to test the VSP circuit. In previous tutorials, you became familiar with a VSP circuit. After connecting the power supply to the electricity, you should measure the voltage of the purple and green wires, where the purple wire is related to the VSP circuit. If purple wire has 5 volts, it means the VSP circuit is intact. Otherwise, the VSP circuit is faulty. The voltage of the purple wire should not be more or less than 5 volts, and any voltage other than 5 volts indicates a malfunction or problem in the VSP circuit. In most cases of malfunction, a 50-volt capacitor in the VSP circuit causes voltage fluctuations. So when you measure the voltage of the purple wire and it shows value other than 5 volts, it indicates that the capacitor associated with the VSP circuit, also known as the VSP surge capacitor, is faulty and needs to be replaced. By replacing the capacitor, you will see that the voltage of the purple wire becomes 5 volts. However, it's important to note that a margin of error within a few hundreds or tenths of a volt is acceptable. But if it measures 5.5 volts or 6 volts and so on, it is considered a malfunction. The next issue is when a whistling sound is heard from the inside the power supply unit before it turns on after being connected to power. You know that when the power supply is connected to the electricity but hasn't turned on yet, the only circuit active and functioning at this point is the VSP circuit. So the whistling sound is related to the VSP circuit. In this case, you need to test the VSP circuit and find the problem. As mentioned, there is a 50-volt capacitor in the VSP circuit. However, the capacitance value may vary in different power supplies. Regardless of the capacitance value, it must be related for 50 volts. Also, when replacing it, ensure that the capacitance value matches that of your power supply. This capacitor, due to the oscillations and connection it creates, causes the whistling noise. So, whenever you connect the power supply to the electricity and hear a whistling sound before turning it on, make sure to replace this 50-volt capacitor to resolve the issue. Of course, in this situation, if you measure the voltage of the purple and green wires and it's not 5 volts, it means there is a problem. The failure of the 50-volt capacitor in the VSP circuit can also cause damage to the capacitors after the transformer. So it's much better that when you replace the 50-volt capacitor, you also replace the subsequent capacitors around the switching IC. Another problem is when the power supply is connected to electricity but doesn't turn on and doesn't start. Sometimes when you turn on the power supply or connect the green and black wires or connect it to a power tester, the power doesn't start. In this case, you should first measure the voltage of the purple wire. If there's no 5-volt voltage on the purple wire, the VSP circuit is disconnected. But if there is a 5-volt voltage, you should also measure the voltage of the green wire. If the voltage of the green wire isn't 5 volts, you need to replace the switching IC because it's damaged. When this IC is faulty, it can't send the command to turn on the power supply, and as a result, the power supply won't turn on. If both the purple and green wires were showing 5 volts, then the IC is healthy, and we need to examine the switching circuit and the transistors of the primary circuit. Because if the switching IC is in good condition, in 99% of cases, the issue lies with switching circuit and these two transistors. If these two transistors are also healthy, then we need to replace the two BJT transistors next to the IC. In many cases, both the green and purple wires show 5 volts, indicating that the switching IC is healthy and functioning properly. So, the problem could be with the switch transistors in the primary circuit. You need to remove these transistors from the board and then test them. If one or both of them are faulty, you replace them, and the problem will be resolved. But if you find that these transistors are also healthy and both the green and purple wires have voltage, then you need to turn to these two BJT transistors located next to the IC or next to the transformer. By replacing these two, the problem will be resolved. Now let's move on to the next issue. The power is connected to the electricity, but only for a moment. For example, half a switch is turned on, or the fan rotates halfway and then turns off. This malfunction is up to 99% related to the secondary circuit, as I indicated here. The secondary circuit is the output voltage circuit of the power from which colored wires are derived, such as green, purple, red, yellow, etc. If any of the components in this secondary circuit, such as these Schottky diodes you see here, become faulty, it causes a short circuit in the secondary circuit. As a result, the circuit before the voltage, which is also connected to the control circuit, causes the power to turn off. The circuit before the voltage is also monitored by the switching IC. If the switching IC detects any connection in the output voltage, it immediately turns off the power. So when you turn on the power, the switching IC detects conditions and quickly turns off the power to prevent further damage. So in such situations, we need to start by testing the components of the secondary circuit. Components such as burnt capacitors and coils are another reason for issues in the secondary circuit. When you solve the problem with the secondary circuit, or when you test and find that all components and connections are fine but the problem still exists, the malfunction may be related to one of the power transistors in the primary circuit. In this case, you need to remove the transistors from the circuit, test them, and if they are faulty, replace them. Usually, in this situation, one of the transistors will be faulty. Another thing you can do to ensure is to precisely follow the steps in this video. First, connect the power to the electricity and place the multimeter in voltage testing mode. Connect the black multimeter wire to the black wire of the power and the red wire to the 12-volt wire. Then connect the power tester to the power and quick connect and disconnect the power tester several times. This will cause the power to turn on and off continuously. In this case, whatever voltage you see on the multimeter, whether it isn't 1 volt, 3 volts, 5 volts, or even 0.5 volts, it means that one of the switch transistors is burnt. This is a trick that tells us whether the malfunction is related to the transistors or the output circuit. Once you've identified and replaced the burnt transistor, also replace the diode and low-ohm resistor associated with this transistor. It's also a good idea to replace the startup capacitor related to this transistor. For example, if this transistor is burnt, its startup capacitor is this one. So in addition to replacing the transistor, replace the startup capacitor, resistor, and diodes associated with it as well. Now, what's the next problem? The power is connected to the electricity, and when we turn it on, we hear a beep sound from inside the power after it's turned on. The reason for this problem once again goes back to the startup capacitors present in the primary circuit. These two startup capacitors, which are associated with these two transistors, cause the primary circuit to start beeping when they malfunction. By replacing these capacitors, the problem will be completely resolved. The next problem is when the power turns on and then after a period of operation, for example half an hour, it turns off by itself. Once again, the reason for this problem goes back to the startup capacitors in the primary switch circuit. In this case, it is better to replace both capacitors and also replace the startup capacitor in the VSB circuit. Make sure that the capacitors have the same values as those on the board and the same voltage. Otherwise, the power will either not work or will not work properly. You might wonder why most problems are related to these capacitors. It's because of their position as part of the inverter circuit in the switch circuit, which was fully explained in the previous sessions. If this capacitor malfunction, the required sinusoidal wave for the transformer's operation is not generated and the transformer cannot function properly, causing the circuit system to fail and the power to turn off. For this reason, these startup capacitors are very important. These capacitors, along with the resistors next to them, should be able to store the oscillating electricity generated by the transistor and consume it. This cycle of storing and consuming electricity is a toggle cycle creating a sinusoidal wave. Alright, up to this point, we've looked into several problems. There are a few more issues that we'll address in the next session. So thank you that you be with us up to now. Please give me a thumbs up that this video was useful for you and introduce our channel to who likes to learn electronics and how to repair devices. So to the next video, take care, see you soon, and bye bye.